Today we are going to talk about the grape powdery mildew model. We select a station in the southwestern part of France and open the grape powdery mildew model. To have a better look of the season, we will zoom out a little bit until we see the beginning of the season. The bottom bar is a summary of the rain periods and the wetness periods that have been recorded by the weather station. Dark blue is for the rain and light blue is for the leaf wetness. The blue vertical line is the last data that was sent by the weather station. So anything that is right of this bar is based on forecast data. Depending on the weather forecast service that you chose, you can have 7 to 10 days forecast. The grape powdery mildew is a fungus that only infects the green aerial parts of the plant. It can overwinter in two ways. As a mycelium in the buds, in this case the grower observes flag shoots with a powdery white coating. These symptoms play little part in the epidemiology of the disease. The second way of overwintering is through fruiting bodies called cleistothecias. They contain the sexual spores of the fungus called ascospores. The model will calculate the primary infection due to ascospores at the beginning of the season and display it with this red vertical line. You can modify this date manually in your local parameters. The ascospores need a rain event, enough wetness and sufficient temperature to germinate and create the primary infection. Once the primary infection has been calculated, the model estimates canidiaphore development. This process depends solely on temperatures and can be interrupted by rain. This is why you have no spore production in the first days following the primary infection, because the climate was cold and rainy. Relative humidity has no effect on the sporulation. As soon as the spores are produced by the canidiaphores, they are released into the air. This is modeled in yellow in the bottom graph. The spore concentration in the air is reduced when you have a rain event or a wetness event, because sporulation is reduced. Once the spores are airborne in the vineyard, they can be deposited onto the leaves. The middle graph is showing the germination of the spores in white. Germination occurs when relative humidity is below 85%, because free water is killing the spores. Germination also depends on the temperatures. Optimum temperature is around 25 degrees. We can zoom in a little bit to see better what is happening. If the spores have favorable conditions for germination for long enough, they can infect the plant. This is modeled in red in the middle graph. Because the development of the fungus is mostly dependent on the temperatures, you can have a series of infection events if the weather is hot enough. The pink area that you can see at the background is an estimation of the susceptibility of the fruits. Indeed, the berries are only susceptible to powdery mildew infections for a couple of weeks. Later infections can attack the green part of the plant, but they won't create more damage on the fruits. The susceptibility is calculated based on the date of start of bloom, and only lasts about 3 weeks after bloom. For the model to be correct, remember to set the date of start of bloom correctly. The top graph simulates the onset of symptoms in a non-sprayed vineyard. Symptoms on the leaves depend on the date of the primary infection, and the symptoms on the fruits depend on the first infections that occurred during the susceptible period. The scale of the symptoms is logarithmic. This helps to visualize the occurrence of the first symptoms, and it explains the flat evolution afterwards. If you have any question regarding this model, send us an email at support@rimpro.eu.